here with me today is my colleague Igor Sokač. Before we continue, just a few announcements. So feel free to ask questions and engage in discussion via the chat. And also this webinar will be recorded. We have disabled the camera stream for participants, so your presence will not be visible on the recording. So we will start recording in a few seconds. Before we dive into the topic, allow me a few words about CROZ for those of you who are joining us for the first time. So CROZ is a Croatian German BizTech company. We do system integrations, custom development, DevOps projects within the AI space, mainframe, business intelligence, and overall IT consultancy. We are headquartered in Zagreb, Croatia, with offices around Croatia, and in DACH, so meaning primarily German market. We are present through our branch offices based in Munich, Germany. For myself, my name is Miroslav Čerkez. I'm a software tools architecture and integration consultant with CROZ from 2013. Started as a Java developer and over the years transitioned into an architecture role, working with complex systems in various roles and industries. Always on the lookout for the next innovation on the horizon. This means that in the past I have been working among the first persons in the company with Kubernetes, with the AI, and now I'm turning my interest into quantum computing, especially quantum safe, which is the topic of today's webinar. And with me here is my colleague Igor Sokač, but I will let him introduce himself. Igor.
Hello, everybody. My name is Igor Sokač, and I've been working with CROZ from 2002, so it's 23 good years. And I've been working in various areas, starting as a system administrator and then moving on to project management and various different areas, including lately IT security.
Yeah, thank you, Igor. So without further ado, why are we here today? Well, primarily what we want to discuss with you is the coming quantum disruption and how it will impact our IT security landscape. Before we dive right into the topic, we would like to conduct a short poll to get a sense of where to put focus during this webinar, so you get the most value out of it. I will ask my colleague Igor to run the poll now. And while you are doing this, I will just briefly read the questions from the poll. So for the first question, how familiar are you with the concept of quantum computing and its potential impact on cybersecurity? Please select one of the answers. Does your organization currently have any initiative or discussions related to post-quantum cryptography? And what do you hope to learn from this webinar? Please give us your answers. I will give you a few seconds more. Yeah, okay. Thank you. I see that answers are mostly across the board, but in most of you have a general understanding of the issue and basic understanding of the quantum threat. So this is great. However, we will try to also put focus on the more advanced stuff. Thank you all for the poll. And let's go further. So what we really want to discuss today are these three questions, and we want to we will try to give you answers to those questions. So the first question is, how does quantum threat impact today's IT security? The second is what quantum safe actually means. And the third one is how to build crypto agility into your organization using IBM Guardium quantum safe product portfolio. So if we dive right into it, so the first question, how does quantum threat impact today's IT security? In order to answer that question, first I would like to spend a little bit time talking about the pillars of IT security, mainly two main pillars in it. One pillar is the people, and the second pillar is the technology. Now, I know for you more security conscious out there, there is also a third pillar that sometimes is used, which is called procedures, but for the purposes of today's discussion, allow me to stay on those two pillars. So the first pillar, the people, is basically where most of our security initiatives today are focused. We are focused on training people, using the system's processes around, using the system's governance frameworks around the systems. And we have built a very layered defenses into our IT security in order to compensate from human errors. Basically, through the education, don't click on the links, rotate passwords, enable two-factor authentication, all the other methods that we have developed over the years in order to compensate for this human error within this security pillar. On the other hand, our general belief is that technology, once correctly implemented, is safe. Why? Because it is proven on the proven hardness of the specific mathematical problems. And this generally means that we acted as people are the weak link and technology just works because it's based on the mathematical foundations. However, the quantum threat basically means that this technology pillar now is becoming under attack because practical quantum computers really attack the technology itself, not the people, but the technology. And how does it do that? It does that through primary two attack vectors. So first is something that is called Shor's algorithm, and the other is Glover algorithm. And in most discussions, this one Shor algorithm is much more prevalent. Why? Because it has a real potential, and it's mathematically proven that it has an ability to break existing public key crypto systems by efficiently factoring large integers, large numbers, and compute discrete logarithms. Now, when we ask ourselves where this public key cryptography is used, so basically everything where we have certificates, where we have asymmetric encryption, those HTTPS calls, TLS protocol on the internet, all of those stuff within your browser, this is all protected by the public key cryptography, asymmetric cryptography, and it is potentially under attack with this Shor's algorithm. Glover's algorithm, on the other hand, attacks the symmetric encryption by reducing the brute force complexity for it. But you can also say that the quantum computers are years away from becoming relevant, and the question is, why should we deal with this right now? So yes, I would agree with you that quantum computers are still not relevant, but on the other hand, the technology is making steady progress over the years. Investments into the area are increasing, and pace of innovation subsequently is also increasing. Just the other day, IBM announced their new chip, their new project regarding in this area, and they put a very aggressive timeline of making the computer that is viable and cryptographically relevant until 2029. So this is quite a high stakes claim from IBM. And the answer to the question, why do we have to deal with this right now, lies in two parts. The answer to that question is in two parts. The first part is that data we generate today have usefulness and value in the future. And especially this data is then under the attack, which we call harvest now, decrypt later. I will explain this in more detail in the future slides. And on the other hand, the technology solution to alleviate this quantum threat is both complicated and complex, meaning that it will take a long time to implement the solution and fixes into our system. So let's dive a little bit deeper into the harvest now, decrypt later problem. So basically, we can summarize it into something which is called Mosca theorem, and this is this simple equation which basically says that the security shelf life of your data, so meaning how long your data needs to be encrypted and secure versus and plus the migration time you will need to make your system quantum safe. If those two times together are larger than the collapse time, meaning that time until we develop a large-scale quantum computer, then we are basically in a problem. When we put this into a graph, what this basically means. So here we have two timelines. So the first timeline is the time which, if we start the migration right now, this is the Y component. So how much time until we are make quantum safe. During all those time, our data can be harvested by our adversaries, and they are also developing this quantum computer that is capable of breaking the encryption. At the point when we complete our migration, so the Y part of the equation is done, we basically have a grace period of our security shelf life, meaning the X variable. And we have to be sure that the security shelf life of the data that we have generated during this time where we were doing the migration does not extend beyond the time where the quantum computers capable of breaking the encryption will become available. So basically this blue line needs to, which extends into this decrypt data part of the timeline. This is the data which is really under the attack, and it is problematic, which we need to, and this is the reason why we need to protect our data today. So in summary, this brings us to the question number 2 that we said that we will be discussing today, and this is what quantum safe actually means. So quantum safe actually means that we want to assure that Y plus X is smaller than Z, so that the data that even if the adversaries today collect our data, this data will not be relevant or interesting to them for a decryption when the quantum computer capable of breaking this decryption becomes available. Yeah. So one word, data you generate before you complete quantum safe migration should no longer be interesting to adversaries once they develop quantum computers capable of breaking the encryption. And now you might say, but what about quantum cryptography? So I want to make very clear and specific statement here that quantum safe does not equal quantum cryptography. So quantum safe is basically a family of solutions run on classical computers that are resistant to quantum attacks. So basically, any computer infrastructure that we have today in our data centers, our laptops, our mobile phones, all of our IT standard, x86, ARM, or any other computer, basically it can be made quantum safe by implementing post-quantum cryptography set of classical algorithms resistant to quantum computer attacks. On the other hand, quantum cryptography is a completely separate science which deals in securing information using the laws of quantum physics rather than really relying solely on mathematical complexity. So this is the really important distinction here. So quantum safe does not equal quantum cryptography. And when we talk about post-quantum cryptography, often abbreviated as PQC, post-quantum cryptography refers to a set of classical algorithms. It is standardized by NIST, and this standardization process actually started back in 2017. So the problem was recognized by the standarding agency quite some time ago. But the trouble is that on one hand, there were like 82 algorithms, 82 candidates, algorithms to be declared post-quantum safe. During this process, which lasted until the 2024, so last year, 4 algorithms are selected for standardization and they are made standard. I have listed them here on the slide, so you can see them for your reference. But the basically idea is, what I want to say with this is that it is very difficult to prove that something is quantum safe because this area of research is still quite new and there is a lot of chatter and a lot of activities doing in the area, and algorithm that is safe today might not be safe tomorrow. That's why we need to think about how to make our organizations quantum safe. And there is, of course, when there is a security in place, there is also a regulatory frameworks that are put in place that are published with specific goals and steps and actions that organizations should take in order to become quantum safe. And there are many such documents. Some are specifically targeted for financial institutions, some are specifically targeted for government, some are specifically targeted for some other specific industries. But overall, if we want to talk about something which is important for us in the European Union, for example, a good document where to start is this one, which is quite mouthful, and I will need to take a sip of water to be able to read it completely. So the document is called A Coordinated Implementation Roadmap for the Transition of Post-Quantum Cryptography. As I already said, quite a mouthful, but basically, what does this document say? It describes a 3-milestone process with milestones and activities and actions that should be completed and goals for each of these milestones. So what are those milestones? So the milestone 1, which has a in my opinion, quite aggressive deadline of the end of next year, basically says that we need to perform our analysis, do our risk assessment, and create our post-quantum cryptography migration plan for our systems. On the other hand, milestone 2, which has a little bit more in-depth deadline, is end of 2030, which says that the high-risk systems, high-risk use cases identified in the milestone 1 activities need to have their post-quantum cryptography transition complete by the end of this 2030. And medium-risk use cases have to be under the migration already by then, and the quantum safe software should be the default. So there shouldn't be any software after 2030 which is developed or put on market on anywhere which is not quantum safe by default. And then the third milestone is the end of 2035, where basically PQC transition should be complete, meaning that all of today's algorithms that we use in rely on security, meaning like RSA and others, should no longer be used anywhere. As you can see, this is on one hand quite aggressive timeline. On the other hand, it can seem to us that it is quite long. But if we take into account that there are organizations that have to keep their data secure for 5, 10, 15, 20 years, for some of them it already may be too late, or they should start their post-quantum cryptography transitions as soon as possible in order to reduce this risk of compromission and successful execution of harvest now, decrypt later attacks in the future. So Igor, do we have any questions in the chat right now?
Check. No.
No? Okay. So if you have any questions during the webinar, please feel free to ask. Yeah, so this is basically the process. And what I want to now discuss next is what milestones, what actions do we need to take in order to achieve the goals from those milestones. So for the milestone 1, we need to identify and involve all the stakeholders. Why is this important? It is important because cryptography is everywhere. There are a lot of systems and organizations usually even don't know and don't have a comprehensive list of all the cryptographic assets, all the places where the encryption is used, either on the edges of the organization, of the edges of the IT system, or even somewhere deep within the system. What we need to do, we need to also create a dependency map, because the nature of the beast is such that you cannot upgrade some parts of the system and leave some parts not upgraded, because both sides in the equation needs to speak the same protocol, needs to speak the same quantum safe algorithm in order for the security to work. We need to perform this, as I already said, quantum safe risk analysis to see whether this system needs to be migrated right now, immediately, or it can be done sometime in the future. We need to include our supply chain. A a lot of organizations rely on software from vendors, and vendors will have to be responsible for upgrading this software. We also know that there is a lot of software out there which has gone out of the support, and there are vendors that are no longer on the market, and companies will have to come up with a plan how to deal with such software, how to make it quantum safe. And for all of this, we need to develop a timeline and implementation plan. And as you can see, it can be quite a daunting task because there will be many moving targets because the business has to go on. We cannot afford to, shut down our systems and do the upgrades. We have to basically exchange our security engines while we are driving on a racetrack. This is really something that I think will be important, and really it's important we start to do it right now. As for the second step, so this is the milestone 2, which needs to happen until 2030. The idea is that by then we have support for cryptographic agility and quantum safe upgrade path clearly defined. We have resources. We have adopted the certification schemes. We have developed the rules, and we know how to do the migration. We have implemented some pilot use cases. We have completed the transition of high-risk systems to quantum safe. So this is basically the step where majority of the high risk and high stakes work will happen. And just to give you a little bit of an example, this is not just an issue of like classical IT where we are talking about like net banking applications, where we are talking about some applications, browsers, mobile phones, chat applications and stuff. There is also a lot of places where we have encryption which isn't obvious to us. For example, in Croatia we have digital certificates in our ID cards. There are digital certificates in our medical insurance cards. There are smart meters, smart home thermostats, a lot of IoT connected devices, which all rely on this cryptography security in order to provide privacy protection for our customers. And this all needs to be upgraded. And the question is whether or not the hardware, which is inside those systems, will support migration to the PQC algorithms. Sorry. And the final step and the final chapter, what it says in this European document, is basically establishment of a risk assessment framework. And here I have highlighted 4 bullets of what are the key performance metrics, which says to you that your system is either medium or high risk, meaning that it should be put under consideration and observation, and PQC migration should start as soon as possible. So basically, there are two dimensions here. One dimension is how long the confidentiality of the data needs to be protected. So if it's at least 10 years, then for sure the quantum risk level is high. And on the other hand, if the transition effort is high, some say there are systems out there that will take more than 8 years to fully migrate and fully make quantum safe. Then this is for sure something where the risk is high, because 8 years is pushing us well beyond this 2029 year where IBM says that there will be cryptographically relevant quantum computers. And with this discussion, this brings us to our question number 3, which is how to build crypto agility into your organization using IBM Guardium Quantum Safe portfolio. And on the forefront of this portfolio is IBM Quantum Cryptography Manager, which I will let my colleague Igor here to say a few words about him. So Igor, the stage.
Thank you, Miroslav. What is IBM Guardium Cryptography Manager? It's a fresh new product. that was announced in October 2025, and actually the new version is going to come out at the end of this month, so in like 14 days. And it's basically a set of tools developed by IBM with a mission to support organizations in implementing crypto agile practices and enabling them to become quantum safe in the future. So to be honest, it's not the first tool or first software of its type. Previously, we worked with something called IBM Quantum Safe Explorer and IBM Quantum Safe Remediator. And those two tools are basically on the market for at least a year, I think now. But the new product that's coming out and that we are going to talk about is this IBM Guardium Cryptography Manager. It's here for the four main functions or use cases. So it's doing the discovery and inventory, it's doing assessment and compliance, it's managing the life cycle, and it's designed to protect and adapt your system to be more resilient against post-quantum cryptography threats. If you remember a couple of slides ago, there was a milestone number 1, which included several steps like identifying involved stakeholders, support mature cryptographic asset management, create dependency maps, and so on. So this tool actually covers many of the functions or many of the steps that are described in that document. And what does this cryptography manager do? Everything starts from discovery. So discovery is basically collecting the data about your cryptographic assets. I'll go into a little bit more detail there, but the first thing you have to do is collect the information about your cryptographic assets. Then you have to create an asset inventory where you store all that information on one place. Then with this tool comes a couple of policies, out-of-the-box enabled policies like NIST policy, GDPR, and so on. But the main strength of the tool is that you can create your own policies depending on your business risks and depending on your IT system. Based on the assets and collected data and these policies, you can calculate the cryptographic posture and then prioritize the remediation steps. And this is just the first cycle. This is the iterative process, which is running all the time in a loop, in a closed loop. So first, something about discovery and inventory. So here the keyword is visibility. Basically, the first step which is being done is scanning the application source code. Usually we do that by connecting to the source code repository, but there are also other ways of collecting the data from different sources, like using Nmap to discover the IT assets and so on. And there is a possibility, for example, to read the SBOM, so software bill of materials, and insert the data about your cryptographic objects in that way. And when I'm talking about cryptographic objects, I'm talking about certificates, key pairs, symmetric keys, libraries, protocols, cipher suits. So after the scanning, you do the discovery and catalog of all those encryption keys and show a consolidated dashboard with all crypto objects in your organization. In this new version, as I already mentioned, there is this set of different ways to get the data into the system. I don't want to go into that details right now. So there is the second step. After we have collected all the data and we have that asset inventory, we can go to the risk assessment phase and create some sort of steps or plan how to maintain compliance or how to become compliant and how to maintain compliance. So the first step would be to assess the risk related to post-quantum cryptography. You need to prioritize vulnerabilities according to your business risks, and then you try to enable remediation. Usually that's running around detecting weak, expired, or misconfigured assets, and also creating enforcements of the policies you define. What this tool is actually providing is also a set of audit-ready reports. So you can basically very quickly show what kinds or what types of cryptographic assets you have, what are the vulnerabilities and what are the priorities, or how is the risk in your environment. Then you can, based on those policies and the data, you can basically see how on a one dashboard you can see how many assets are critical, how many are quantum vulnerable algorithms that are being used in your environment, and also it provides numerical exploitability scores, which are actually a function derived from the business impact you define by yourself, and the code assets or the hard data coming in from the vulnerability of the existing crypto objects. So like libraries and crypto algorithms. Okay. The next step is remediation. So basically what you need now, now you know what you have. You have everything stored. You know how you have defined your policies, and you have defined the risks. You know what order of actions you need to take. Then you go to the remediation steps. It can be something as simple as basically selecting some library or class and then changing the lines of code, or it can be something automated by opening tickets on the ticketing systems like ServiceNow or Jira, and then following and tracking those tickets until those assets are being fixed or remediated in some other way. So when we are talking about remediation, we are talking about code changes, which is, as Miroslav said, a big problem for itself. And also you can do remediation in some other ways, like implementing tools. IBM has IBM Quantum Safe Remediator, which is basically a set of forward proxies and reverse proxies that are used in cases where you cannot modify the source code, but you basically protect the communication between the system components using quantum safe algorithms. So everything gets translated into quantum safe compliant algorithms. Communication between the system parts is working, and you don't have to change much in your environment. This is just, let's say, a temporary, this is used for a temporary
Stopgap.
Thank you, as a stopgap solution to basically protect yourself from different types of attacks, and not change the code itself until you have enough time or money or enough people to do the changes themselves. And basically, this is it. These are the 5 steps of functions, or 5 functions that Quantum Safe or IBM Cryptography Manager does. Miroslav, back to you.
Yeah, so thank you, Igor, and thank you all for listening. And I will just like to invite you all, if there is any questions or comments, please feel free to share them via chat. And to wrap things up, I would just like to address it and to give you a short summary. So if your organization is currently on a quantum, becoming quantum safe on a quantum safe path, or is thinking about becoming a quantum safe, so the first step would be to identify all the assets that need to be updated and need to be made quantum safe. There is a tool, as Igor said, called Quantum Safe Explorer, which can help you scan your code. You can put it into your CI/CD pipelines in order to have a continuous monitoring and continuous scanning whether or not the cryptography objects that you currently have in there and which will be introduced in the future are quantum safe. On the other hand, you need to then start, you can use this information to start planning the remediation steps. And if there isn't a possibility to update your existing source code, then there is this option of going through the stopgap measure and implementing the reverse proxies, which can then talk quantum safe between the organization, between the components. But please bear in mind that this is really a stopgap measure, and really a plan should be that your software natively speaks quantum safe algorithms in the future. And where is crypto agility in all of this? So the important thing here is, as I already said a few slides before about this, when we were talking about the standardization process, there is no guarantee that any of the standards that are currently standardized, like all of those 4 algorithms, that will remain quantum safe also in the future. So when we are becoming and you are designing the process for your organization and changes to become quantum safe, also think about in terms of automating this process, so that in the future, if there is a proof that the currently algorithms that are thought to be quantum safe really are not, that there is an agility on the organizational level to be able to rotate those implementations, those algorithms into some other that will be developed, that will be then the next state of the art in terms of quantum safety. There are some researches that suggest that the average lifetime of a certificate, which is today around 180 days, will go as low as 20 days, which means that we will have to be much more vigilant and much more agile in our ability to maintain and manage our cryptographic assets through our whole IT environment chain, to be able to keep our system secure in an ever-evolving environment on the internet and also within our organizations internally. And with that, I would like to close this. If there aren't any questions and comments, thank you for your attention, and hopefully we see ourselves on the next webinar next week, when we will be discussing IBM web methods. Thank you all.
Thank you.